Hello everybody, this is Video Boy and welcome to LibGDX 2D tutorial part 12. Alright, so this episode is going to be out a little bit early just because there's no devlog this week, so I thought I might as well do two tutorials. They're fairly quick to make anyway, so why not? So today we're going to be adding collision detection for the bullets and the asteroids. We're not going to do it for the player ship yet. We're going to do that in the next episode. And we're also going to do a little bit with fonts today. So let's get right into it. So what I like to do for collision detection, I like to create a new object type called collision rect. Although there might be a little bit of noise because I have the window open. Alright, so let's create a new package because it's not really something that has to do with screens or entities. Whoops. New package. Alright, dot tools. So it'll be tools. We can put some stuff in there. Some stuff we'll put in there for future episodes as well. When we do future episodes, like cameras and things like that. Alright, so let's create a new class. Call it collision rect. Alright, so basically the collision rect has four variables. So it has x and y. And it has a width and a height. So let's create the constructor. So basically the collision rect is used to check if it collides with another collision rect. So we'll do that code in a second. Let's just do the basic constructor stuff. So float x, float y, int width, int height. Alright, so then we set x to x, this dot y is equal to y, and this dot width is equal to width, and this dot height is equal to height. Okay, we also need to do a move method. So move. The reason for this is because the x and y, just copy that, the x and y of what we're going to be colliding with isn't always the same, so we need to be able to move the collision rect as well. Alright, so this is the important method, so public boolean. So what it's going to do is going to return a true or false value of whether or not it collided with the other rect. So boolean collides with, and then we'll pass another collision rect. Okay, so when we use this, we're going to say like, asteroid dot get collision rect. So we get the asteroid's collision rect, which would be like an object like this. Then you do if collides with, and then we'll say like, I don't know, player dot get collision rect. So that kind of thing. So we need to write the code here to see if it collides with another collision rect. So the code for that is very simple. So it's actually kind of like a condition. You know when you do conditions, you can add them together. So you do like and or. So just say like player dot x is less than 5 and player dot y is more than 5. Something like that. You can add them together, but what you're doing here, when you do these conditions, is you're actually creating a boolean. So what you can do is you can actually return this boolean. So return. Alright, so what do we need to check if we collide? So we need to check if the x of the current rect is less than the x of the past rect, x, plus its width. Okay, so I'll explain these in a little bit. And the y is less than the y of the current rect plus the height, recta height, and the x plus the width of the current rect is more than the x of the past rect And finally, the y plus the height of the current rect is more than the height of the past rect. Alright, so basically this is a condition. It's going to return true or false depending on if the condition's met, and it's going to return it as a boolean, which a boolean is true or false, right? So what are we checking exactly? Alright, so let's look at them in steps. Alright, I'll actually do a diagram right now. I'll do it live. Might as well. So here, let's do a red rectangle. Okay, and then we'll do a blue one. Okay, so we need to check if these are colliding. So visually we can see they are colliding, but how can we check using code if it is colliding? So as we saw the first condition here, if the x, okay, just say the current one, it would be the red rectangle, and the blue one would be the rect dot one. So if the x of the current rectangle is less than the x of the blue rectangle plus the width of it. So remember the x of the red rectangle, here I'll use black, so the x is here. So it's the coordinate right there. We need to check if this is less than the x of this rectangle plus that. So basically we're just making sure that this x is either from here to here. So it crosses out anything in this zone. Okay. So it makes sure that the x is at least here. Alright, I'll check the next condition. So this one's very similar. It's if the y is less than the y of the blue rect plus its width, its height, sorry. So the y is also here. If it's calculated from the bottom left always. So if the y is less than the y of this rectangle plus its height. So if it's either all the way up here or down here, from up here, so if it's less. So this automatically cuts off this whole zone here. Okay? And the next condition, if the x of the red rectangle plus its width is more than the x of the blue rectangle. So the x of this rectangle plus its width, we want to make sure that along here is more than the x of this. So as we can see, it is. So we need to make sure, so it crosses off this whole zone here. It makes sure that it's colliding in this area. Alright, and the last one is the y plus the height of the red rectangle is less than, is more than the height of the blue rectangle. Hold on, I think I might have done that wrong. Let me check real quick. Yes, I did it wrong. It's not height, it's y. As you can see, they kind of mirror each other. Like there's the x1 and there's a y1 and x1 and the y1. So it checks if the y, which starts here of the red rectangle, plus its width is over the y of this one. So it checks if it's over. So it finishes off and it cuts off this last region. So basically it perfectly checks if the two rectangles are colliding with each other. And that's pretty much how it works. So I hope that kind of cleared it up for you guys so you could understand it. There's much more difficult collision detection in other games. There's polygons and stuff like that. But for now, you're all beginners here, so we'll just stick with squares for now. And we could even do circles later on because they're pretty easy too. Okay, so let's get back into the code. So this is all set up now. So let's actually set that up with the asteroids and the bullets. I'll be right back in a second. Sorry about that, just had to mute Skype. Okay, so yeah, let's actually set this up so that the bullets and the asteroids have their own collision rectangles. So let's create a collision rect object here. Let's call it rect. Control Shift O to import it. Alright, and then let's initialize it, so this rect is equal to new collision rect. Okay, so we need to pass x, y, width, and height. So x and y, will just x, y. The width and height for the bullet, let's create constants for it. So the width is 3, and the height is 12 for the bullet. We're just using the image width and height, which, by the way, we will change at the end of this episode. Also, this episode might be a little longer than usual, but I'm pretty sure you guys will be fine with that, because you guys usually like longer episodes. So, okay, so now we create the rect. Now what we need to do in the update, once the bullet moves, we need to update the x and y of the rect as well. So we need to move it. So we do rect.move, and we'll just pass the x and y. Okay, so now let's create a getter here for it. Collision rect. Get collision rect. I don't think I've talked about getters previously, but getters are getters are methods that return a value, so like a parameter. So this one returns the collision rect. So the reason we do this is because these values are usually private and they're not visible from outside of this class. So we do this so that they are visible from outside, and we can get them from the main game screen, which we're going to do in a couple of minutes. Alright, so here for the asteroids, it's basically almost the same code. So we'll just copy it over. Copy. Here, put that like that. And we'll copy over the getter as well. And the move code, don't forget that. Alright, sweet. Well, save everything. Okay, so now we need to actually check if they do collide. So now we have it set up so that each asteroid and bullet has a collision rect, but there's nothing that actually happens in the game yet. So we need to actually check. So when do we want to check? Well, we want to check once we make sure that every bullet and every asteroid is updated so that they're at the position they're supposed to be. Lots of people would actually check in the update method while they're being updated if it's colliding with another object, but it's good to wait until they've all updated their position and their positions aren't going to change, and then you check if they're colliding. So let's do it here. So after all updates, check for collisions. Okay. So we need to create a for each loop. So for each bullet in the bullets list, alright, so we didn't actually talk about embedded for loops, but basically we're going to loop through each bullet, and then each time we loop through a bullet we're going to loop through each asteroid. So that way we're going to check if each bullet and asteroid have collided with each other. So each one's going to check with, so each bullet's going to check with each asteroid if it's collided with it. So how do we check that? Well, it's very simple because of our nice code. Do if bullet dot get collision rect dot collides with. So if the collision rect of the asteroid, the bullet collides with the collision rect of the asteroid. So collision occurred. Is that even a word? So what do we want to do if a bullet and an asteroid run into each other? Well, we basically want to remove the bullet and the asteroid. We're also, when we add font in a couple of minutes, we're also going to update the score. So how we're going to remove it? Well, if you guys remember when we remove the asteroids that go out of bounds, or when we remove the bullets that go out of bounds, we had this array list. If we don't have it, we get a concurrent modification error. So instead of removing it right after the update, we can actually just remove it later on. So I'll remove it here. Instead of just removing them all right away, we'll remove it when we're completely done checking for all the collisions. So then here we can easily just do bullets to remove dot add, and then we add the bullet, and asteroids to remove add asteroid. Alright, so let's try it out. There you go. Now it does look kind of weird. They just disappear randomly, but we'll add some sort of explosion animation later. Okay, so that's good. Now let's add the score counter. That's going to be very easy to do. So if you guys check the GitHub, I uploaded some assets for this episode. You're going to need the stuff in the fonts folder, so the score.fnt file and the score.png file. So these are just font files that LibGDX uses. I believe it's not JSON, but it uses some sort of parser to get data for each character. If you actually look at the image, see? So it's a bitmap font. It uses an image and it crops out the parts it needs for the different letters, and it displays it on the screen. So we're going to be using the bitmap font included in LibGDX. So let's create that object. So bitmap font. Let's call it font, or yeah, let's just score font. Oops. Alright, we need to import it, of course. Alright, and let's initialize it. Score font is equal to new bitmap font. And if you press Control Space, it'll show you all the different constructors. So the one we want to use is we want to use this one because we want to get it from a file. So how do we get it from a file? We do gdx.files.internal. So when we're looking for an internal file, it means we're getting it from the assets folder. There's other ones you can get files from the hard drive and things like that, but we just want to get it from the assets. Okay, so the path to it is fonts /score.fnt. Alright, so now we need to actually display the score and everything. So let's actually create a score object real quick. Score, and when the game starts, we'll set score to 0. Okay, and of course what we want to do is when a bullet shoots an asteroid, we want to update the score. So let's add 100 to the score. Alright, sounds good. And let's actually draw it now. So how do we do the actual score? So what we want to do, we want to center it on the screen. So a good habit to have for doing that is to use a glyph layout. So a glyph layout, let's call it score layout. Basically what it does is it uses a font that you give it and the text, and then it does some calculations based on it. So it calculates the width and height of it, and it does a bunch of other things like that. But basically all we need for it right now is a width and height. So let's create a new glyph layout. Alright, we're going to use this constructor. So we need to pass a font, so we'll pass score font because that's the font we're going to use. And the text, we'll just simply do this. We can't just simply pass score because score is an integer and it's asking for a string. But as a workaround, we can make it a string and just add the score. Okay, so now let's actually display it. So font dot, that's true, we call it score font. Score font dot draw. We use this constructor that needs a glyph layout. So we need the batch, so game.batch. For the layout, we'll pass score layout, and this is an X and a Y. So we want to center it, right? So how do we center things again? We get the width of the screen divided by 2 minus the width of the object we want to display divided by 2. So score layout dot width divided by 2, and we want to do it at the top of the screen. So GDX dot graphics dot get height minus score layout dot height. So minus the height, and then we'll give like a 10 pixel buffer from the top of the screen. So let's actually do this. Alright, there you go. It's a 0, and if we shoot stuff, it updates. And that's it. By the way, this is the same font that I use for Archipelago as well. It's called Press Start. It's a completely commercial, free to use font, so you guys can make games with it. And I didn't make it, by the way, someone else made it, but it's a great font, and you guys can make games with it and stuff, and you won't be charged or anything, so that's awesome. Anyways, that ends off this episode. It was pretty long, but there was a lot of stuff. Next episode we're going to be adding actual explosion animations. Real quickly though, we're going to try to do that real fast, and we're also going to add a health bar for the player. So it will be a longer episode like this one, but we're going to get a lot done, and it's going to be pretty awesome. We won't do the game over screen just yet, I don't think. That'll be for the episode after. But anyways, thank you guys for watching. If you enjoyed this episode, please leave a like, and if you have friends and stuff who want to learn game development as well, please share this video with them. It helps to grow the channel a lot. And I'll see you guys probably in a few days, because I'm going to upload 2 episodes this week. So, see ya.